Hi, thanks for joining. Please make sure you subscribe to follow us on all the various platforms here on the podcast, as well as on YouTube. The stuff we write on Substack, as well as quick takes on Instagram and on Threads. If you're enjoying what we're putting out there, please make sure you're sharing with all your friends and family. And if you have questions or comments about the stuff we're putting out there, please make sure you leave them in comments to us. We'd be more than happy to cover them in future talks.
Well, as we go ahead and change the clocks ahead, I think it's a good opportunity for us to go ahead and revisit a discussion we had previously around the same time of the year, actually, about daylight savings time and what it's actually going to do to our body and why it may or may not be the best idea that we have in terms of moving the clocks forward versus moving the clocks back and all the various time changes that we might have and how our body's going to respond to these these hour shifts that we arbitrarily put into our calendar year. So let's go ahead and let's take a look at and listen to the discussion we had about a year ago as it relates to daylight savings time and what we can expect physiologically to take place because of the time change and why it may or may not be the best idea that we have.
Warning. The following presentation contains information that might contradict what you have previously heard, or believed to be true, about how the human body works, and contains material that is not suitable for closed-minded individuals. Enjoy.
We've changed the clocks. We're waking up what feels like in pitch dark. We're going to bed when the sun is still up. That's right, it's daylight savings time. And we hear a whole bunch of stories in the news about how daylight savings time is going to impact us in terms of our overall health, in terms of our productivity. But how might that come about? What is the underlying rationale for all of the issues we might see in terms of health changes or in terms of loss of productivity due to simply moving the clocks ahead 1 hour? Is it just us feeling jet lag for a week? Or is there something else underlying the reasons for the health concerns that we might have with using daylight savings time? Well, let's talk about that.
So, to start the discussion, I think it's important to understand what jet lag is and how jet lag is actually going to be different from what we might experience over the next few days, next few weeks, as we slowly adapt to the new time that we might be in. Jet lag is the psychological and physiological responses that we tend to see when we are going to travel to time zones that are at least 2 hours different than the time zone that we happen to be in. That's what jet lag is. And since we're not actually changing time to the point where we are 2 hours ahead, 2 hours behind in terms of what our normal time might be for our regular everyday activities, the feelings that we get as is associated with the changes in the day due to daylight savings time isn't really going to be jet lag. One of the things we have to look at when we start looking at the issues as it surrounds both the psychological as well as the physiological responses that we have to daylight savings time is that we are changing times following a stable pattern of changes in amount of daylight that we have throughout the day. During this time period, we are slowly adapting to these natural, I guess you can call it natural rhythmic changes that we see within our environment that are leading to natural rhythmic changes that we might see within our body based off of adaptations to what is usually referenced as our circadian rhythm. Our circadian rhythm is our natural sleep-wake cycle. That natural sleep-wake cycle is based off of a host of hormonal and neurotransmitter responses that we have within our body, where we're sending signals around the body, hormones, that are going to be changing the metabolic activity in cells and in tissues of the body that are going to elevate levels of fatigue and feelings of tiredness that get associated with changes in the neurotransmitters, the signals within the neurons within our brain, that tells us, okay, it's time to go to sleep. A lot of times this discussion about this circadian rhythm is referenced as it relates to a single hormone, and that single hormone usually is melatonin. But it's not really just about melatonin. That's one of the myths and misconceptions out there as it relates to why am I tired? Why am I fatigued? Why am I jet lagged? Why am I having all of these issues? While melatonin is important it's not the single thing that's going to be triggering those natural circadian rhythm responses. The natural circadian rhythm responses is based off of a host of internal and external signals, internal and external cues, signals and cues that are coming from inside my body as well as from outside my body, from the environment. That's going to alert me to when should I be awake, when should I be sleeping. And if we're going to do this based off of whatever references as being quote unquote natural, we're going to do it based off the amount of blue light that we're exposed to. And the amount of blue light that we're exposed to will change how cells within the pituitary gland, cells within the hypothalamus, and cells within the pineal gland within our brain are going to be functioning based off of their own hormonal secretions and their own neurotransmitter secretions, so that we signal the brain to be awake or signal the brain to be asleep. If we're going to signal the brain to be awake, what we're going to do is we're going to change the neurotransmitter responses to be more excitatory. And when we're talking about more excitatory neurotransmitters, what we're really talking about is glutamate, dopamine, noradrenaline, also referred to as norepinephrine. And we're going to be reducing the neurotransmitters like serotonin and like GABA. By swinging those neurotransmitters in that fashion, what we're able to do is we're able to get the neurons to start to fire more rapidly or fire more regularly. But there's another neurotransmitter, there's another hormone signal that comes into play that's going to impact the glutamate, the dopamine, the noradrenaline or norepinephrine signals that act as a depressant, act as an inhibitor to the activation of the neurons that is coming about from metabolic activity that is usually referenced as, that's usually associated with, usually associated with high amounts of metabolic activity that is going to necessitate my needing to rest, my needing to sleep. And it's not just metabolic activity from the body as whole, but metabolic activity from the neurons itself. And that metabolite, that hormone, is adenosine. And so adenosine is a chemical that we usually see in terms of adenosine triphosphate, ATP, that is a molecule that all the cells use for energy. It's the energy molecule when we think about energy for the cell. But when ATP is used, it gets broken up. And one of the byproducts of getting broken up is adenosine. And what ends up happening is that the adenosine will then go into local circulation or will go into full body circulation. And when it goes into full body circulation, it'll get picked up at various areas. It's one of the things that can cross the blood-brain barrier. And when it's involved with neurons, what it does is it slows down the rate at which neurons are able to fire, the way in which neurons are able to become active. And when the neurons slow down their firing rate, it's the indication that it's time to sleep. And so as we go through the day, we are constantly building up small amounts of adenosine. And as the adenosine starts to build up over the day, we start getting more inhibition and more inhibition and more inhibition on the neurons, to the point where the neurons start to slow down. When we combine that with changes in blue light in the environment, we get a combination of various signals that increases melatonin production and melatonin release from the pineal gland that changes whether or not we're going to be having the excitatory neurotransmitters, the glutamate, the dopamine, the norepinephrine or noradrenaline. And we're going to swing towards more of the inhibitory neurotransmitters, things like GABA, things like serotonin, as well as that modulator of excitatory signals, the adenosine, that's going to slow down brain activities. And when I slow down brain activity, that's where I'm going to start to feel tired. And so one of the things that happens when we start having these changes in daylight savings time is that we start to disrupt part of that signaling. We really don't disrupt the adenosine signaling, because that adenosine signal is going to come from my metabolic activity. What we are going to disrupt is we're going to disrupt the amount of blue light that I'm going to be exposed to. It's that amount of blue light for reasons why we don't want to have any of our electronic devices with us next to the bed or near the bed if we want to have quote unquote good night's rests, because the devices that we use have high intensity blue light. The amount of blue light changes during the day. And so one of the things that I remember back in my intro to biology class, we were just discussing scientific principles. And one of the questions that got brought up is, why is the sky blue? And why is the grass green? And it's all about some physics in there in terms of refraction and reflection of light, not to go into this whole sidetrack in terms of that discussion. But when the light coming from the sun interacts with all of the molecules in the atmosphere, we get bending of the light, very similar to a prism bending light to form a rainbow. And when this interaction takes place, what ends up happening is that the amount of light in the blue spectrum of light gets maximized, and it gets maximized throughout the day. So at dawn, it's not that much. As we go through the day, it becomes more intense. And then as we get towards night, it becomes less intense. And it's that blue light that's going to trigger this swing towards the excitatory end and block the inhibitory end. And so when we start looking at, okay, why am I feeling sluggish? Why am I feeling tired? Part of it has to do with the fact that we have changed our responsiveness to that blue light simply by changing when am I going to wake up and when am I going to go to sleep? Because we need those changes in blue light to match the changes that I have within my swings of adenosine and other metabolites that's going to indicate time to sleep. It's that kind of, and any of my students are listening, it's the hey dummy signal, where we have to listen to our body. And that hey dummy signal of, okay, adenosine's high, metabolites that say we've had too much metabolic activity are high, blue light has gone away, it's time to sleep. But what's happened is that we have shifted that response. We have shifted that response, not drastically like we would see with a jet lag issue, but just minimally. And so why is it that minimal change going to lead to the issues that we might see in terms of neurological issues, health issues surrounding daylight savings time? It's not that we're becoming sleep deprived, because sleep deprivation takes multiple days to come about. Why is it that we're feeling lethargic? Why do we have moodiness around daylight savings time? It has to deal with a lot of the change in circadian rhythms that's going to come about due to mismatches that occur in between the environmental cues of sleep-wake with the internal physiological cues of sleep-wake.
And unlike how it's usually discussed, it's not where, oh, you're losing an hour of sleep in the spring and gaining an hour of sleep in the fall. That's not actually what's happening. Even though we think about, oh, we're skipping an hour in March and we're repeating an hour in November, what we're really looking at when we start looking at the impacts of the daylight savings time is, what does that mismatch do in terms of our physiology and how that physiology is going to impact all of the outward signs that we express whenever we have these time changes, where we note that in terms of health issues, there's increased risks for cardiac events, increased risk for myocardial infarctions, heart attacks, increased risk for fibrillations, increased risks for atrial fibrillation, increased risk for ventricular fibrillation, increased risk for other cardiac events, increased risk for strokes. We note that there are issues in terms of delays in reaction times, where we note an increased relative risk for traffic collisions in the days following any type of clock change, whether it is the spring forward into daylight savings time or the fall back at the end of daylight savings time. It doesn't seem to matter whether we move the clocks up or move the clocks back in terms of the physiological responses that we see
and the outward expression of those physiological responses in terms of how we interact with each other in the environment. We see changes in judgment. We see changes in frontal lobe cognitive processing. We see changes in mood and mood regulation. We see increased agitation. We see reduced empathy and reduced sympathy that comes about from these changes in daylight savings time. A lot of this has to deal with some of the internal and external stressors that we might see at play when it comes to these daylight savings time events. We might have issues as it relates to changes in neurotransmitter actions. We might see changes as it relates to having an imbalance in between excitatory signals and inhibitory signals within the brain that lead to these impaired judgment issues, this impairment in decision making, this loss of some control of our emotional regulation. A lot of symptoms that are, once again, very similar to symptoms that we might see where we happen to have sleep debt, where we are not getting enough rest, enough sleep in between the days. But it's a little different. Actually, it's a lot different than just developing sleep debt, even though we are developing sleep debt. We can't just take care of it by taking naps. We can't just take care of it by consuming coffee or consuming some sort of caffeinated beverage. Even though taking a brief nap, taking a caffeinated beverage, something with caffeine in it, can help in the very immediate aftermath of waking up from the nap or immediately after consuming the caffeine, because napping will help clear some of the metabolites that are causing the imbalance to occur. Caffeine will help with blocking the adenosine signaling, which will help with the regulation of neuron functions to make it seem to the neuron as if everything is functioning normally. And we don't have an accumulation of metabolites that say we've done a lot, we need to rest. So we can take care of these things in the immediate with quick fixes, with naps, with caffeine, but it's not going to help with any of the long-term ramifications that we might see from these changes in times, from this swing in daylight savings time into daylight savings time or out of daylight savings time. And why is that? That's because having this mismatch between the daylight exposure to light and the internal signals of high metabolic activity can lead to dysregulation taking place within the cells. Dysregulation within the cells that can lead to alteration of genetic regulations, alteration of epigenetic regulation, alteration of the transcriptional factors, the factors that are going to regulate when genes get turned on, turned off, when genes activity that determines when proteins are being made within the cells that are necessary for metabolic functions, that are necessary for repair to take place, that are necessary for growth to take place within the tissues. And this is where we have to start looking, okay, what are some of the things that we might be able to do to counteract and counterbalance this mismatch that's taking place? Is there a way to, quote, hijack, end quote, that circadian regulation, that circadian rhythm that's taking place that gets disrupted? And this is where some people will become a proponent of taking dietary supplements that can act as surrogates to the normal hormonal signaling that we might get. And this is where you might hear about people saying, oh, take melatonin, or oh, take magnesium, or drink warm fluids. Take these supplements, drink this fluid at times where you would normally be going to sleep based off of the 24-hour clock that we use to regulate our day, as opposed to the environmental clock of when is the sun visible, when is the sun not visible. But the problem is that using these supplements does not cure the issues. It's, once again, it's a quick fix. It's very similar to taking the nap, drinking the caffeinated beverage. It's providing a quick fix. It's not actually changing the physiological responses that we're having based off of what the environmental cues are and based off of what our metabolic cues are. Taking the supplements may seem like a good fix, may seem like it's something that will be of benefit, but at the same time, it may actually cause even more dysregulation to occur because we're disrupting the normal regulatory processes that the natural production of melatonin will be used for. Even though we think about melatonin in terms of sleep-wake, the production and secretion of melatonin is regulated by a host of factors. One of those factors happens to be the amount of sunlight that's there, and particularly the amount of sunlight triggering the amount of blue light that I'm being exposed to. But the other thing that's going to be regulating melatonin is things that are going to be regulating serotonin as well. And remember, serotonin is going to be that neurotransmitter that's going to reduce neural activity. It's going to make me want to feel tired. But it's also going to be associated with a reduction in the amount of norepinephrine, noradrenaline, the amount of glutamate that is being used by the neurons. That when I am taking this exogenous melatonin, so exogenous coming from outside the body, when I'm taking this melatonin as a supplement, people say, oh, it doesn't cause habits. Oh, it doesn't cause adverse effects. The problem is that we can't make those statements because we don't have the studies to back it up. While there is no evidence in literature to say that taking melatonin supplements has negative impacts on our physiological functions, at the same time, there's no long-term studies about what does the supplement of melatonin do to my normal circadian rhythms, my normal circadian regulations. Especially when we're taking this melatonin as a cure for nighttime sleep, but neglecting what happens because I'm waking up at a time where environmentally I'm getting a signal that I should still be asleep. It's that mismatch in between what the 24-hour clock is telling me and what the environmental clock is telling me. And because I have this mismatch in between what the environmental clock is telling me and what the 24-hour clock is telling me, is even though I might be taking melatonin in an attempt to get sleep during the time where, based off the 24-hour clock, I should be sleeping, I'm still going to have signals from my body, hormonal signals, metabolic signals, because of the misalignment between the two clocks. I'm still going to have that misalignment, and that misalignment is going to lead to sleep issues. Sleep issues where I could become sleep deprived, not just have sleep debt. And that sleep debt is something that can accumulate over time. I cannot pay it back. I cannot all of a sudden, oh, I'm going to take a nap and make up for the sleep that I'm missing. That's not how sleep debt works. It's not like having normal bank debt. It's not like, oh, I owe money, and so I'm going to pay it off over time until I don't owe any money. Sleep doesn't work that way. And if we have a discrepancy in between the environmental cueing and the biological cueing, I'm going to have an inability to have appropriate sleep. And if I do not have appropriate sleep, in the long term, I'm going to have a lot of metabolic issues that can come about. I'm going to have a lot of cognitive issues that can come about. And it's, once again, it's not about jet lag. It's about the mismatch that I have in between. What does the biological clock tell me? What do all of the physiological signals in my body tell me? And what does the environmental signal tell me? The environmental signal is telling me that I should be awake at later points in the day, even though my clock, the 24-hour clock, is telling me I need to be asleep. While on the opposite end, the environment is telling me I should be sleeping when my 24-hour clock is telling me it's time to wake up, it's time to go to work, it's time to do the things I need to do on a daily basis. And it's something that we continually get reinforced that we will adapt to, which we will. Very similar to if I happen to move between time zones, I will adapt to the new time zone I happen to be living in. Or if I happen to travel and I travel between time zones, I will adapt to that new time zone in terms of my normal circadian rhythms. But it takes time to do that. And having these abrupt changes within the yearly cycle, even though we know when those changes are going to occur, we get disruptions that can take place, which leads to the question that I always ask is, can we do better? Is there a way that we can make these changes less physiologically taxing, less psychologically taxing, that allow us to utilize the daylight savings issues without having the ramifications on our health as relates to what the daylight savings times do? And the answer to the question is yes. There's always opportunities for us to do better, but how can we do better? This is where we have to take into account kind of the transitions that we might do if we happen to be traveling between time zones, particularly when we know when events are going to come up. We know that daylight savings time is going to start on day whatever. In this case here, it started on March 10th, 2024, and it will end on November 3rd, 2024. So we know it's gonna run from day one to day whatever. It's gonna run in between these two dates. We know daylight savings time is gonna be this time. We know standard time is gonna be this time of the year. We can make it so that we establish within our own personhood a change in our normal rhythms in the weeks leading up to the transition in between times, where we have slow, methodical changes. And those slow, methodical changes will allow for small adaptations to take place. It usually takes between a week and 2 weeks for physiological adaptations to come about based off of the stimuluses and the stresses that we're being exposed to. And so if I can utilize the week leading into the daylight savings time and the week coming out of the daylight savings time, I can be better prepared for any of the physiological and neurophysiological or psychological effects that might come about from having a daylight savings time changes. That's the easy fix. The harder fix, at least politically the harder fix, even though a lot of people are more in line with this than has been in the past, is to look at, do we actually need to have daylight savings time? And there's two kind of sides to this battle. Side one is always use daylight savings time, which is not the best option. And I'll explain why here in a second. The other option is to always use standard time, which once again may not be the best option. If we look at what we utilize the daylight savings time for within the summer, we're really looking at it in terms of having extra daylight for outdoor activities. And we need the extra daylight for outdoor activities, or we have to artificially light the environment to allow for activities to take place later on in the day. The artificial lighting that we use is not going to be as disruptive in terms of our normal physiological responses if we're to utilize artificial lighting in the environment. It has environmental impacts to it, but it doesn't have physiological impacts to it. And so if we start looking, okay, let's keep standard time throughout the year, the physiological effects of staying on standard time is going to be minimized in terms of not having these transitions in between days. And because I'm not going to have these transitions in between days, I'm not going to have the ramifications of, I'm not going to have the effects of the daylight savings time on my body. Now that on the Counter to that, it means that if I want to have little league games, if I want to have soccer games, if I want to have basketball games outdoors, if I want to have volleyball games outdoors, if I want to have soccer outdoors, if I want to have any type of activity outside, it's going to indicate that I need to artificially illuminate the outdoors. Artificial illumination outdoors may not impact us physiologically simply because of the type of lighting that we use, but it can have an environmental impact in terms of light pollution. And that light pollution can have an impact on wildlife and can have an impact on environmental cues for organisms that are normally diurnal, nocturnal, that is daytime living and nighttime living in the environment. It could also have an impact for those of us that actually like to look at the stars in the sky in terms of the ability to see the stars due to light pollution that we might get exposed to, because we're going to have more light pollution in order to allow for the extra play, the extra time outdoors, if we were to utilize strictly standard time. And that would be more light pollution than what we already have in terms of the amount of light pollution in the environment. But on the opposite end, we have a push by some that say, oh, we should have daylight savings time year round. Why move the clocks ahead? Why move the clocks back? Let's just keep daylight savings time year round. Well, there was an experiment that was run on that. And we can call it an experiment, even though at the time it wasn't really an experiment. Where the idea was that I want the daylight later in the day so that I have the outdoor activities. I have the ability to be outdoors longer in the day. I don't care about the morning time. But they forgot about the fact that children are commuting to schools. And this is back when a lot of students, children, were walking to school. And there was a rash of traffic accidents against pedestrians because the drivers couldn't see the small children walking in the pitch dark, because at 7 o'clock, it's still dark, particularly if we're looking at this being daylight savings time. Particularly if we're looking at it being daylight saving time in the spring or in the fall, when we have, or even worse, in the winter, when we have less hours of light than we have in the spring and in the summer. And so the idea is that, well, we can't do this permanent daylight savings time simply because of the health risk, the public health risk that comes about from needing to illuminate the environment very early in the day, which is just as bad as needing to illuminate the environment into the night in order to allow for outdoor activities. And so even though both propositions indicate, oh, well, we can make these changes, and we can make these changes to not have to deal with the constant clock change that we see with the daylight savings time, both options aren't very good. And both options aren't very good because we're trying to fit our 24-hour clock into an ever-changing environmental light situation, where instead of altering our 24-hour clock to the environment, we're trying to alter the environment to our 24-hour clock. It'd be much easier and much wiser, both physiologically as well as psychologically, to alter the 24-hour day that we use to match what the environmental cues happen to be than the other way around, even though for business purposes, for political purposes, for personal preferences, we choose the other way around it. The fact that we want to somehow control and or manipulate the environment to fit our needs, as opposed to utilize our needs to fit inside the environment. Which leads to why we have long-term issues related to daylight savings time. And while we indicated changes that we associate as relates to metabolic signals relating to high amounts of metabolic activity. What we talked about in terms of melatonin releasing as it relates to changes in signals coming from the pituitary and the hypothalamus based off of exposure to blue light that comes about from signals from our eyes and from the optic nerve going into parts of the brain that then relay out into the hypothalamus, into the pituitary, and into the pineal gland. We have other hormonal signals that are associated with sleep-wake cycles. And some of these hormones are associated with growth signals, and some of these hormones are associated with inflammation signals. Sometimes referred to as counter-regulatory signals. And so when we start looking at these other hormonal signals, we get other hormonal responses that get disrupted when we start looking at these daylight savings times that can and do lead to long-term issues from having this constant swing that we can mitigate to a certain level by doing small little changes in the weeks leading up to needing to have this new daylight time or this new 24-hour time, because we become fixated on the 24-hour clock as opposed to utilizing the environmental clocks that we're given. The natural rhythmic changes that we see in terms of day length will have an impact on our melatonin production. Will have an impact on our level of activity. But we also have to look at, okay, when are we going to see distinct rhythmic regulatory responses within hormone production that's going to allow for tissue repair, that's going to allow for tissue growth, that's going to allow for normal fuel utilizations. This is where we start looking, okay, when are we going to start seeing spikes? When are we going to start seeing large amounts of hormones such as growth hormone, large amounts of hormones like cortisol? What we usually think about cortisol as it relates to inflammation responses, cortisol has a normal regulatory response, a normal rhythmic response based off of our sleep-wake cycle. And when we get disruptions in our sleep-wake cycle, one of the things we're going to see disruptions in is with cortisol. But we're also going to see disruptions with growth hormone. We're also going to see disruptions with vasopressin, and also referred to as antidiuretic hormone. We're also going to see changes in oxytocin response. We're going to see these hormones that are normally responsive to diurnal switches within daylight, switches within our sleep-wake cycle that regulate not only my stress responses, but also my tissue repair responses. Where if we have this swing, and what ends up happening is that when I have this disruption in sleep-wake cycle, I get a shift in my hypothalamic pituitary adrenal axis. That's the stress axis that is responsible for my quote-unquote fight or flight response. And when I have this shift in my fight or flight response, I end up seeing changes towards a stressor where I'm going to get increased sympathetic activity, but I'm also going to see increased inflammatory signals. And those increased inflammatory signals is also going to be seen with increased cortisol. And so we have this moodiness, we have this change in mental awareness, we have this change in cognitive function. Some of that cognitive functional change can be associated with not having appropriate amounts of time for neural recovery from the day prior because cortisol is spiking at wrong periods of time. Now, that cortisol spiking is also going to be seen very close to waking time. And that has to deal with cortisol being one of the multitude of triggers in terms of regulating blood glucose levels and regulating hunger responses. One of the reasons why we wake up is because of changes in cortisol. It's usually a delay of about 35 to 45 minutes in between when we see a early morning spike in cortisol and waking up. Part of that has to do with the fact that when cortisol increases, we get changes in noradrenaline or norepinephrine signals, which causes a change in a small little area of the brain that's usually referenced as the reticular activating system that leads to changes in responsiveness to melatonin signals, to serotonin signals, to glutamate signals, to GABA signals, to dopamine signals that changes activity within the brain that leads to more alertness, more arousal, more awakeness that comes up. And so when we start having these changes in stress signals, we start having the internal and external stress of having a mismatch in between what does the environment say and what does my work clock say, what does my day clock say. I'll see a change in that cortisol signaling, which can cause a disruption in inflammatory responses, in tissue repair responses, but it's also going to cause a change in when I'm going to feel alert or not. The other hormone that we can see disruptions in is that growth hormone response. The growth hormone response is going to be kind of counterbalanced by the cortisol response in terms of the tissue repair. We have to remember is that we grow and we repair during sleep cycles. And because we grow and repair during sleep cycles, we're going to see spikes in the hormones that are going to be regulating growth and repair during that sleep cycle. Any disruption in that normal circadian rhythm 24-hour clock, if we want to think about it as a 24-hour clock, any disruption or misalignment in between when should I be sleeping based off of metabolic signals versus when should I be awake based off of metabolic signals is going to disrupt the hormonal responses that we see that's going to allow for tissue repair to take place. This can lead to some of the metabolic dysregulation that we see, some of the metabolic diseases that can come about that have been associated with daylight savings time issues and maladjustment to daylight savings time. But at the same time, these irregular growth signals, this irregular stress signal, can have an impact on cognitive functions. One of the bits of educational research that is out there has shown that student performance is negatively impacted by daylight savings time changes in the school clock. Part of it has to deal with not getting the appropriate environmental cues to be awake versus being asleep. But the other part is that the students are not getting the neural repairs that are necessary to allow for all of the information that was learned previous day to be structurally hardwired into the brain so that they're able to learn new stuff. They're able to associate what was done the day before, the week before, with what's being done today. And so we have all of these maladjustments that can come about from having these daylight savings time adjustments to the 24-hour clock relative to the environmental cues, all leading to external and internal stresses, which cause the physiological responses that we see, and the physiological responses that we see are all associated with excessive stress responses that can lead to metabolic dysregulation, genetic dysregulation that cannot be counterbalanced simply by the quick fixes. Simply taking melatonin in order to fall asleep is not going to lead to a regulatory response that's going to obliterate, that's going to eliminate the negative impacts that we see from having the daylight savings time on our physiology. Simply drinking the warm glass of milk, which is going to lead to a change in neurological tone, which is going to put me at ease, if I happen to be lactose tolerant, if I'm able to digest dairy products, it's not going to eliminate the physiological issues of having this malalignment between my 24-hour clock, the way in which I break up the day, and the environmental cues as to what the day should be. There is no quick fix here. There is no way to get around it. We can do small adaptive changes leading into the daylight savings time changes, where we have to pay attention to, okay, on this day of the calendar, clocks are going to change and I have to adjust. I have to adjust what I'm doing leading into those time changes so as to not have the malalignment, misalignment in my own physiology, where the stresses and the stressors and the metabolites that say you need to sleep have been cleared because I've slept enough. Even if the environmental cues are not exactly correct. But without that, there's no way to get around it. There's no way that we can eliminate the stresses of daylight savings time without eliminating daylight savings time. Increasing the amount of coffee that we're drinking for the next week. While we may take a few more naps over the next few days, simply to survive the changes that are taking place, all we're doing is surviving until we adapt. We adapt to the new change, and then November comes and we're going to have to do the exact same thing. There is some evidence that says that the time moving back to standard time is not as stressful as the time moving from standard time to daylight savings time. But there is not enough research out there to definitively say that that's the case. We do know that having these changes lead to physiological stresses, and the physiological stresses are known to cause metabolic issues that are known to cause dysregulation in terms of dysregulation to metabolism and dysregulation to genetic regulatory agents. Changes in enzyme functions, changes in protein development within the cells to either repair or to grow tissues. We see very similar things taking place for people who are constantly traveling in between time zones and do not have appropriate rest and recovery within the time zones. But it's not the same. What we're seeing over the next few days is not the same as what we see if we happen to travel, say, from California to New York and suffer from jet lag over the first few days that we're there. It's not the same, even though it might feel the same. Well, thanks for listening. Hopefully you got a little bit out of this brief discussion on why daylight savings time is kind of screwing up our physiology and making us feel the way that we're feeling. Please make sure you're liking. Please make sure you're subscribing. Give us that 5-star rating and review on the publications. We very much appreciate it. It's going to help us out with the algorithms. Make sure you're following us on all of the various platforms, whether here on the podcast, on YouTube, in the Substack, as well as the quick takes being posted onto Threads and onto Instagram. Thanks a lot. Hopefully you are surviving the daylight savings time and are making the correct adaptations to the new time.